in SAS Studio. You view a data table, write and submit SAS code, view the log and results, and use tasks to quickly generate graphs and statistical analyses. SAS Studio is a browser-based programming interface that connects to a local or hosted SAS server. The server processes the code and then returns the results to your SAS Studio session. When you first open SAS Studio, you see a navigation pane on the left and a work area on the right. The navigation pane provides access to folders and the libraries that contain your files and tables. The Folders section is displayed by default. The work area displays a program window with tabs for your code, log, and results. When you open data and run tasks, other windows appear in the work area. Let's start by viewing a SAS table. In the navigation pane, I'm going to select Libraries, expand My Libraries, and then expand the SAS Help library. I'll double-click the Cars table to open it in the Table Viewer on the right. The Cars table contains 15 columns and 428 rows of data. The Table Viewer displays one page of data at a time, and each page contains 100 rows. You can use the arrows to navigate between pages. Notice that column names are displayed by default. You can switch to column labels if you want. In the Columns area, all the columns are selected by default. You can clear the checkbox for a column to remove that column from the viewer. If you'd like to customize the view, you can hide the Columns area, maximize the Table Viewer, and resize columns as needed. You can right-click a column heading to filter and sort the data by that column. I'm going to add a filter to select only the rows with invoice values greater than or equal to 30,000. At the top of the table, you can see the number of filtered rows. As you select options and customize the table, SAS Studio is generating SAS code. To see the code that creates the table, I'm going to click the Display the Code button on the toolbar. A new tab opens with the code that was used to create the current view of the table. If you want, you can save the code for later use. I'll close this Program tab, exit the maximized view, expand the Columns pane, and switch to the Program 1 tab. Now I'll write a SAS program that will enable you to see the Cars data in the form of a report. As I begin to type, you'll notice the context-sensitive help. I'm going to turn off this feature now, but later I'll show you how very useful it can be. I'll start by typing a procprint statement, beginning with the keywords procprint. Then I specify the table name, sashelp.cars. I end the statement with a semicolon and then complete the program with a run statement that also ends with a semicolon. Now I'll submit the program by clicking Run. Notice that the results from the program are displayed after the code runs. I'm going to check the log to make sure that the program ran without errors. The log shows that SAS read 428 observations, or rows, from sashelp.cars. There are no errors or warnings. When I look at the results, I see a report that displays all the data from sashelp.cars. I can scroll to the bottom to see all the data. The default results format is HTML, but I can use buttons on the toolbar to download results in RTF or PDF format. By the way, I can change the style for each format by using the Results page on the Preferences menu. I'd like to modify this report to view only a subset of these results. Before I write my program, though, I want to turn on the autocomplete feature of SAS Studio again. I'll click the More Application Options icon and select Preferences. In the Editor section, I'll select Enable Autocomplete and then click Save. I open a new Program tab by clicking the New Options icon and selecting New SAS Program. I'll begin again by typing procprint. Notice that the help for the print procedure includes syntax for the options, as well as direct links to related SAS documentation. I'm going to complete the procprint statement by specifying the table name. Then I'll use two of the options that the procprint syntax suggests. The cars table is sorted by make, so I'll include a by statement to specify that I want the output to be grouped by make. Secondly, I'll use a var statement to specify that I'd like the columns make, model, and type to be included in the report. I'll run the program. The results display the data grouped by make. Now that I look at these results, I'd really like to include the columns that provide gas mileage data. I'll go back to the var statement to add those columns. Unfortunately, I don't remember the exact names of those columns. SAS Studio has a great shortcut for just this type of situation. In the navigation pane, I'll expand the cars table. I can select the columns that I want to include and drag them directly into the var statement. I'll submit the program again, and the results now include the additional columns. In addition to features that make writing SAS code faster and easier, SAS Studio also includes powerful point-and-click tasks that quickly generate reports and graphs. Let's take a quick look at two of these. In the navigation pane, I'll select Tasks and Utilities, expand Tasks, expand Statistics, and double-click Summary Statistics to open the task. I'll click the Select a Table button and select the table that I want to use, sashelp.cars. Let me maximize the view so that I can focus on the task. Next to Analysis Variables, I'll click the plus sign and select Weight. Notice that SAS Studio automatically generates the code for the means procedure. On the Options tab, I can specify which options I'd like to use. I'll accept the default selections this time and just run the program. The results of the analysis are shown in a summary table. I can save this analysis if I want so that I can reuse it later. Now let's look at a graph task. I'll exit the maximized view and in the Tasks section, expand the Graph area. Then I'll double-click Bar Chart to open the task. Once again, I will maximize the view to better view the task settings. I'll select Fish as the data table in the SAS Help library. I'll select Species for the category variable. Notice that the default measure is a frequency count. I'll select Variable for the measure, and then Weight for the variable. Sum is the default statistic. I'll change that to mean. On the Appearance tab, I can control the details of what the bar chart will look like. I'll add a title, Average Weight for Different Species. Modify the bar details, and then run the program. I've very quickly created the chart that I need. Remember that I can save the results in HTML, PDF, or RTF format, which makes this chart very easy to reuse and share. You've seen the power of SAS Studio to run analyses and quickly create graphs and charts. You can view the additional videos in this library to learn more.